Okay. Y equals mx plus b is the slope-intercept form of an equation. 2x plus 5y equals 10. This one's in standard form, so we need to get it in this form, so we're going to have to solve for y. 2x plus 5y is equal to 10. The way you start this is you bring this 2x term to the right side of the equation. You want to leave the 5y. To make a 0 from a positive 2x, you subtract 2x from both sides of the equal sign. So that leaves you with 5y is equal to, now the 10 does not have an x with it, so do not combine it with the 2x. I'm going to go ahead and put the minus 2x in front of the positive 10. That way when I finish, it'll be in the slope-intercept form of a line. We're almost done. All you have to do now is to solve for y. This is multiplication, so you solve by dividing by 5. You divide the left and the right sides, and I like to divide both terms by 5 so you won't forget that you're dividing the x term and the constant. So on this one, 5 divided by 5 is 1, so y would equal negative 2/5 x plus 2. 10 divided by 5 is 2. Negative 2 divided by 5, it would be a decimal if you tried that in the calculator, but for slope you do want to leave it in a fraction form. The b is always your y-intercept, if you want to write that in your notes. And my suggestion is that you plot that point first. So on the graph, since 2 is positive, you're going to go up 2 on the y-axis. Don't forget, this is your y and this is your x-axis. You might want to label those. And once you've plotted your point of your y-intercept, the negative 2 and the 5, you can think of your slope as a rise over run. You might want to write that down so you'll remember that means rise over run. So rising 2 and running 5, because it's negative, you're going to run to the left. So after you rise 2 and run 5, and then you, if you want to go down 2 and then over to the right 5, you'll have the same pattern. And it would be good if you'd use a ruler. I'm going to get a ruler to connect your dots. If you have a ID or something straight, you can use a ruler to draw your linear equation on the graph. I always put arrows to show that this equation does continue indefinitely. And that's called a linear equation. Now the word system is when you have 2 or more linear equations. Let's write the definition. A system is 2 or more linear equations and to solve a system, sorry, I'm not spelling that right, S-O-L-V-E, to solve a system means to find the point at which the graph of the lines intersect. I'm going to read that again. A system is 2 or more linear equations like the one we just did, and to solve a system, it means to find the point at which the graphs of the 2 lines intersect. If you look at number 2 has 2 equations. We're going to have to solve for y for both of these equations so that we can graph them. I'm going to recopy the first one. X plus 2y is equal to 2. And then I'm going to copy the second equation next to it. 2x plus y is equal to 4. And I'm going to solve both of those for y. If you look at the first equation and we move the x term, we have to subtract it from the left side and the right side of our equation. So 2y, remember the x term and the constant cannot be combined, so you will have to write that as a negative x plus 2. Now to remove the 2 and leave the y, you're going to do the division of 2. Make sure you divide all three terms by 2. When you divide 2 by 2, you'll get 1y. This means a negative 1 right here, so go ahead and write it as negative 1/2 x. That's how you would read that coefficient in that 2. And then 2 divided by 2 does divide evenly, so 2 divided by 2 is 1. So that's your first equation. Let's go ahead and graph this equation. And remember to graph the y-intercept. I'm going to make a little arrow to this 1 and help you remember. This is the y-intercept. This number in front of the x is your slope. So the y-intercept is at a positive 1. Remember the y-axis is the vertical axis. The horizontal axis is the x-axis. So we're going to plot the y-intercept first at a positive 1. And then you're going to use the slope of up 1 over 2, but make sure it is negative, so it will slant to the left. So you rise 1, run 2, rise 1, run 2, rise 1, run 2. If you keep the pattern going below this point of intersection, it would go down 1 and to the right 2. So here's what the pattern would look like. I'm going to go ahead and take a ruler and draw that line. The more you put on the graph, the more exact you're going to find your intersection. So now I'm ready to graph or solve for y for my second equation. This is the second equation, the 2x plus y equals 4. I'm going to move the x term first by subtracting 2x on both sides. I'm going to get y equals negative 2x plus 4. That one was a little bit easier because we're already done. We've got it in slope-intercept. The 4 is the y-intercept, and the negative 2 is the slope. So this time the 4 would be the point of intersection on the y-axis. So go up 4 from 0 and plot your point. And then since your slope is a negative 2, you will rise 2 and run 1. Since if you want to turn that one into a fraction, you can think of it as a over 1. So if you go up 2, make sure again you go to the left 1 because it is a negative slope. You keep the pattern, you continue it. You'll go down 2 over 1. I can already tell where this one intersected, but let me draw the line to show it to you. You should be able to put your ruler down so that it hits all the points. That's your second line. And if you look at your graph, this is the intersection point. The intersection point is called the solution, and I'm going to write solution, and I'm going to put it as an ordered pair because that's where the point is. The x value is 2 and the y value is 0. And that's the intersection, so that's the ordered pair. That's the solution to a system. Alright, let's go to the next page, number 3. I'm going to teach you another method to solving solutions of systems. On this one, number 3 says to solve by substitution. Now what that means is you're going to solve not by a graph. We're not going to need a piece of graph paper for this one. If you'll look at the variables, the coefficients on the x are, this is understood to be a 1 and a 4 and a 2 and a negative 3. So if you want to solve by substitution, you want to pick one of the variables that has a 1 for a coefficient, and you want to solve for that variable. So on this one, I'm actually going to solve for the x in the top equation. So that's the one I'm going to solve for. So let's do that first. We're going to solve x plus 4 y equals 1. This is the one I want to solve for, so I want to take the 4y and bring it to the other side of the equation. So x would equal 1 minus 4y. Now this is the value, the expression that we're going to use, and we're going to substitute to solve. But we have to substitute it by putting it in the second equation. See the x next to the 2? This is kind of our step 2. This is step 1. The second step is to take that second equation, and where the x is, we're going to replace this quantity. This right here will now be the x value. And then I'm going to keep copying the equation, the second equation. See how now the second equation no longer has two variables. It just has one variable, the y, because we took the value of x from the first equation and replaced it for the value of x in the second equation. Now it's got a y value that we're going to solve for. You need to distribute your 2 times 1 and 2 times the negative 4y, so that's a negative 8y minus 3y is equal to negative 9. Now because you have y terms that you can combine, you need to put those two together, so that would make it 2. Negative 8 minus 3 is negative 11 equals negative 9. We're still trying to solve for y, so we do need to move the 2 first. To get rid of the 2, we have to subtract the 2 on both sides of the equal sign. That makes the 2's cancel out. You have now 11y. A negative 9 minus 2 is a negative 11. If you divide by a negative 11 to make the y value 1, or the coefficient 1, the answer is actually 1, because a negative 11 divided by a negative 11. Now that's actually one of our answers, because we have our y value. The third step, I've run out of room here, so I'll put it right here. The third step is to take this value and replace it for the y back in that first equation. So let's go back to that first equation that we had, and remember x was equal to 1 minus 4y. Well, the y value now we know is 1. We're going to replace that in for the 1. So now the answer for x, make sure you multiply before you do anything with this first one. You have to follow order of operations. So the order does matter. Negative 4 times 1 is a negative 4. And when you subtract 4 from 1, you do get a negative 3. So that's our x value. Now when you write your answer in an ordered pair, your solution can be written in an ordered pair. You have to list your x and then your y. So negative 3, positive 1 is a solution. Now if you want to use your calculator to check the solution, you can always replace the negative 3 for the x value and the 1 for the y value. You could do that with both equations to see if you got the same answer, the answer in the equation. That's called substitution. Now the elimination method is a little bit different. Elimination is when you decide to remove one of the variables by making the coefficients opposites. When you study this one right here, let's eliminate x's. The only way I could do that is if I created a coefficient in front of each x that was an opposite integer. So it looks like because we have 2 and 5, if I took the top equation and multiplied by a negative 5 and the bottom equation and multiplied by a positive 2, I want you to notice what's going to happen. I'm going to put the resulting problem to the right. Now you do use, the reason I put parentheses, you do use the distributive property. Negative 5 times 2 is negative 10. Don't forget the x. A negative times a positive is a negative, so it's negative 15y. And a negative times a positive is a negative, so equals negative 25. When you multiply through the second equation on the bottom here by 2, you're going to get a positive 10x, a positive 8y, and a positive 32. You're multiplying the 2 times all of those terms. Now draw a line, and now you're going to combine all your like terms by doing the math up and down. The reason this is called elimination is because we've just eliminated the x term. See how you get a negative 10 plus 10, and that's now eliminated. You don't have that anymore. So negative 15y plus 8y would be a negative 7y. And then on the right side, negative 25 plus 32 is a positive 7. If you divide by negative 7 on both sides, you will now get a negative 1. Now remember, when you solve a system, you're not just solving for one variable. You're solving for x and y. So we have to go back and take one of our equations and replace or substitute the value for y. I think I'll go back to the top equation, and I'm going to copy the top equation, and then underneath it I'm going to replace the y value with a negative 1. So I'll just put a negative 1 instead of the y up in the problem. So 2x, make sure you multiply, and a positive times a negative would be a negative. So you get a negative 3 equals 5. Move the 3 first by adding 3 to both sides. So 2x would equal 8. Then divide out the 2. So your x would equal positive 4. And remember, you want to write your solution as an ordered pair. So 4 is your value of x, and negative 1 is your value for y. And that's the solution of a system using the elimination method. Now the next one, you can choose to do however you want.
Teachers, if you are finished